Okay, completing the square and turning point. So today we're going to look at how we can take the polynomial form quadratic and turn it into turning point form, because as we know when we're graphing, it's easy to graph turning point form. So we're going to look at, and the way we get it from polynomial down to turning point form is we do the process of completing the square. Okay, if we remember or consider this x plus a squared, if we saw that pattern, I asked you to expand it. You know, you always, the first term gets squared, then we do 2 times the other 2 terms times together plus a squared, the last term squared. So when we're completing, if you think about that, this last term here is half the coefficient of the 2a. So this 2a here, it's half of that, so that's why I'm dividing by 2, and then it's that squared. So if you look there, you would have 2a divided by 2 is a squared, see? And we get that. So that's what we're going to think about when we're doing our completing the squares. Okay, so if we look at this example, x squared plus 6x minus 2. Now, this is not a perfect square, meaning this is not one of the patterns, because we can see that this negative 2 is not a squared term, and it's definitely not, there's not 2 times it. This should be, if that was going to be perfect squared, this number here would have to be 4x, but it's not. So we're gonna try and make this a perfect square scenario by adding or subtracting a term into it so that we can make it a perfect square. Okay, so to find the term that we're going to add and subtract, we are going to halve that coefficient in there next to the x, which is 6. We're going to halve it, so 6 by 2. So you're halving the coefficient of x, and then you're going to square it. So if you think about it, 6 divided by 2 is 3. So, and then we're going to square it. So it would be 3 squared, which equals 9. So we're going to add that into our equation. So if I've got my equation there, x squared plus 6x, and I'm going to add my new term in this part right now. So I'm going to add 3 squared in there. Now, because I added it, that will change the value. So that's why I'm going to subtract it as well. So I'm going to do that. And we can't forget about the negative 2 that was there in our question, so we leave that in there. So what I have done is I've added a term, but I haven't changed the value because I've subtracted it. So that's where I've written the note up here. We can create a perfect square pattern by adding and subtracting a term. Okay, so now this is a perfect square pattern, which I could factorize because this term in here is exactly 2 times the other one. So I can factorize that using my pattern, so that one would be x plus 3 squared. Now, and I've got to add the rest, so over here, we've got minus 3 squared minus 2, so that's 9 minus 2, so I end up with minus 11. Okay, so now I have completed the square, and if you look, I have my quadratic in turning point form. So if you remember what we were speaking about, so we're in turning point form now, and then we've done it. So if you were thinking about this graph here, so remember our basic graph was like this. This graph has moved over to the left 3 and down 11. So if you're graphing this one, this is just roughly, so there we go. We'd say -3, 11 is our turning point. Okay, so now we've learnt how to complete the square so that we can get a quadratic into a turning point form. So this is turning point form. And we could see that makes it easier for us to graph the quadratic. Now, if you remember, we're talking about when we're graphing, we should show the points of interest, which could be the x-intercepts. So to find the x-intercepts, we know that's when y equals 0. Alright, so if I let 0 up there, that means we've got a quadratic equation equaling 0, which is good because that's how we solve a quadratic equation. So when we're solving, we factorize it. So we've got to look at this. We have one squared term minusing another term, but that term, it's not a squared term, but we can make it a squared term. The way we can make it is, if I said the square root of 11 and I squared it, we know that that's square root 11 times square root 11, which ends up equaling square root of 121, which equals 11. So essentially you can say, if you write square root 11 squared, that's the same as writing 11. So I'm going to write my quadratic equation here in turning point form. Instead of writing 11, I'm going to write square root 11 squared. Now, this is one of the patterns. It's a squared term minus a squared term, which we know factorizes to the first term minus the second term, and then the other one is the first term plus the, it doesn't matter which way you write it, but there's the two things. So we're trying to find the x-intercepts. So the null factor law, well, it says that we can let them equal 0, which means we'd end up with negative 3, x equals -3 plus or minus square root 11. So if you're thinking of the graph of this quadratic, so we saw before that it moved to the left 3 spaces, say 1, 2, 3, and down to -11. So we had it down there, so whatever, and it does whatever the thing is. So that was my turning point, -3, 11. Now we've got these two intercepts now, the x-intercepts there. So one scenario will be that x will equal -3 minus square root 11, and this other scenario will be when x is -3 plus square root 11. If you think of the square root of 11, it's roughly 2, so it still will be in the negative here. But as long as you're showing that, so if you wanted to show the coordinates, you just simply write -3 minus square root 11, 0.
Save time.